Yeah, I don't know why I like gravity as much as I do, but I do, and I'm not going to hide it. There are gravimeters scattered around this office floor. Um, it has come in handy in the work that we do in Greenland. We would measure gravity from the plane. You know, gravity is an attraction to a mass. Where there's more mass, there's more gravity, and so we use those measurements to figure out what the topography or the bathymetry, which is topography when it's underwater, is when you can't measure it by other means. And so you can fly over. And if there's a hill on the seafloor, you'll get more gravity. And if there's a trough on the seafloor, you'll get less gravity. And so we had the gravimeter on the plane mostly so that we could map the shape of the seafloor around the margins of Greenland. It's really important for us to understand what the depth of the water is around the coast of Greenland. In Greenland Rising, it's important to understand that to the nearest meter so that we can understand how it's going to change. But in the previous projects that we did, we just needed to know, like, what is it to the nearest 100 meters? Like, that's the level of ignorance that we had about the seafloor. And that's important because there's warm water offshore in the ocean. And if it can travel in through a fjord and get to the grounding line of a glacier, then the warm water will melt the ice more quickly, and ice sheet change will happen more quickly. And the way ocean circulation and water currents move is steered very much by the topography, the bathymetry of the seafloor. And if you don't know what that water depth is, you don't know how that water is going to move, and you don't know how you're going to move heat into the ice sheet and how you're going to melt it. So when we try to put numerical models of understood processes to play them forward and see what the world's going to be like, we need to know how deep's the water. And you can't tell that around the coast of ice sheets because there's ice in the way. And that was important for those big whole Earth models of sea level change. So now that we've moved into this human-sized project, we have been going in a boat, and we've been measuring with sound echoes what the seafloor topography is. We get a higher resolution. But if we had a gravimeter on that boat, which we don't, we would be able to detect more what the subsurface was made up of. So we'd maybe be able to see the contrast between piles of sediment and crystalline rock, and so understand the geology and the history a little better, because that's the cool thing about gravity. However many constraints you have on the landscape, gravity will tell you one thing deeper, and so it's always telling you something.